Hello and good afternoon, everyone. We are group 5 of Object Oriented Programming, working on the project titled Hospital Management System. The main goal of our system is to efficiently manage patients, doctors, and appointments in one integrated platform. Originally, we were tasked to create classes for patients, doctor and appointments, implement inheritance, and ensure all data is stored in files for persistent access. This matters because it means faster access to information, organized patient records, and better scheduling, which can directly improve hospital efficiency and patient care.
Our target audience includes hospitals, clinics, and healthcare administrators. Basically, any healthcare facility that needs to manage patient information, staff records, and appointments. The benefits are clear. It reduces paperwork and physical storage needs. It saves time when searching for patient or appointment details, and it also improves accuracy by validating IDs and keeping records in a consistent format. Now that we know who this is for and why it matters, let's move on to a live demonstration to see how it works.
I will now guide us through the live demonstration. On screen, we can see our main menu. First, we will log into the system using the username and password. This is our basic security layer to ensure only authorized staff can access it. Let's go ahead to register a patient. Patient's ID, full name, patient's age, contacts, patient registered. Let's go ahead to book a doctor's appointment for this registered patient. Patient ID of 890. Doctors available for that day are listed below. Let's choose the dates for the appointment. 25. Now, let's go ahead to search for a patient who has forgotten her patient ID. This patient has an emergency and needs to be allocated to a nurse immediately. Her name is Esi. Esi's patient ID has now been displayed. Let's go ahead to allocate a nurse to patient Esi. Her patient ID of 256. Emergency. Nurse allocated to patient. Let's go ahead to view the appointment history so far. This is all the appointment history so far. Let's go ahead to exit the terminal. I will now hand over to my teammates to go through the features in detail.
This part explains three main features of the hospital management system. We have one, the login system, which checks username and password against stored credential for security. We also have the patient registration, which uses the patient class to save details like the ID, name, age, and contact, both in memory and a file for permanent storage using the upstream. We also have a feature which is the appointment booking, which uses the appointment class to link patient's ID with their doctor's ID and the date, verifying both IDs before saving to prevent errors. Overall, these features ensure a secure and organized workflow for hospital staff.
The next set of features includes viewing appointment history, which is done by reading through the appointment file with IfStream and displaying records that match a given patient or doctor ID. We also have doctor and nurse allocation. This uses the doctor and nurse classes, both inheriting from person. The allocation process links available staff to patients and stores this link in the file. We made a key design choice to use a menu-driven interface instead of commands, with prompts and confirmations to reduce user errors and make it easier for hospital staff with little technical background.
So, from a technical perspective, this program is built entirely in C++ using object oriented programming techniques. Then, our architecture is made from three main parts. The first part being the main menu model, which handles user navigation and triggers the right functions based on user input. Our second part focuses on the classes with definitions for persons, doctors, nurses, patients, and appointment details. The last part we have focuses on the file handling functions which store and retrieve data using the OF string for writing and then the IF string for reading. And then finally the iOS function for appending without overwriting. Our program flow is very simple, where the user selects from a list of menus. We get input from the user, we validate, and then see when we retrieve that data to or from a file. And then we also use cross checks to ensure that IDs are valid before taking action.
The backbone of our code is the person-based class, which contains common attributes like name, ID, and contact info. The doctor, nurse, and patient classes inherit from person, using its fields and functions, but adding their own unique ones. For example, doctor has a specialization field, and patient has medical records. We also use constructor overloading so objects can be created with either no data or full details in one step. Polymorphism comes in through the display function, which is declared as a virtual function in the base class. This means we can store different object types in a person array, a person pointer array, and still get the correct display behavior at runtime without knowing the exact object type in advance.
Of our main challenges was learning and implementing fast storage. Initially, we struggled with overwriting old data and inconsistent formatting. We fixed this by using iOS app mode for appending and structuring each record in a predictable format. Another challenge was retrieving and searching data. At first, searching by patient's ID or name was slow and error-prone. By reading line by line and validating against stored IDs, we made the search more reliable. We also face input validation issues, like preventing appointments from being booked for non-existent doctors. This was solved by checking IDs across multiple files before confirming actions. These challenges taught us how to handle file input output more efficiently, plan data storage in advance, and write cleaner, more maintainable code.
In conclusion, our hospital management system brings together core programming concepts like object-oriented programming, inheritance, polymorphism, and file handling to solve a real-world problem in healthcare management. By combining patient registration, appointment scheduling, and staff allocation into one efficient system, we've created a tool that reduces manual workload, improves data accuracy, and speeds up hospital operations. This project has not only improved our technical skills, but has also taught us the importance of planning, collaboration, and user-friendly design. We believe that with further development, this system could be scaled for real-world hospital use, delivering even greater efficiency and better patient care. Thank you very much for your attention.